Yeah, in the last video we discussed about electric field and electric field lines. In this video we are supposed to discuss properties of electric field lines. But before going into properties of electric field lines, I'd like to discuss something else. That is uh, principle of superposition of charges. Superposition of charges. What it is exactly is, okay, if you have a point charge plus q here, and here is a system of number of charges. Here is a charge plus q1 minus q2 plus q3, a number of charges, and here let us say minus qn. Here is a system of charges. Here's one charge and a number of charges q1 till qn. Some are positive, some are negative. The distance of q1 from q is r1. q2 is r2. q2 from q plus q. This is r3. Like that you have a number of charges and distance of qn is rn. Now, principle of superposition of charges gives you the resultant force acting on charge q due to this entire system of charges, point charges. Due to the first charge q1, the force acting on q will, both being positive, will be repulsive, and it will be in this direction, F1. What is F1? It is the force acting on charge q plus q due to plus q1. Now, force acting on plus q due to minus q2 will be attractive. These two will attract each other. It will be attracting each other with this force F2. The force acting on plus q due to q3, both being positive, will be repulsive. Let us say it is F3. Similarly, the force acting on q due to qn, which is negative, being attractive, will be in this direction, Fn. So this plus q is acted upon by a number of forces, F1, F2, F3, dash 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 up to Fn. So the resultant force acting on q due to all these charges is given by principle of superposition of charges as vector F is equal to vector sum of each of these forces. You have learned vector addition. This is principle of superposition of charges. You may state it as follows. That is, if a number of charges are interacting with each other, that means they are exerting forces amongst themselves, then the resultant force acting on one particular charge is equal to the vector sum of the forces acting on it due to each individual charge. What is that? Principle of superposition of charges is understood, or it is also mentioned in the textbook, I think, as force between multiple charges. Force between multiple charges. So, is this clear? Now, you can apply the same principle of superposition to find electric field at a point due to each individual charge. Before that, what was this F1 which we had shown just now? Vector F1 would have been K capital Q Q1 upon R1 squared, unit vector R1. What is F2? K Q into minus Q2 upon R2 squared, unit vector R2. What will be Fn? Force acting on Q due to the qn charge Q1 was also a negative charge before. So you have to find the forces acting on charge capital Q due to each of them by using each these formulas, and then add them up vectorly. Vector addition you have learnt in 11th standard. Okay. Now principle of superposition can also be used to find the intensity of electric field at a point due to a number of charges. Let us see how it is done. Now here is a system of charges: Q1, Q2, Q3, Qn. I want to find the intensity of electric field at this point P, which is at a distance R1 from, I'm taking this negative, I'm showing Q4 also. Q4 is negative, positive, positive, positive. Q2 is at a distance R2 from this point. Q3 is at a distance R3 from this point. You can put vector signs or vector position vector of P with respect to each charges. Rn, sorry, R4, Rn. The resultant intensity of electric field at this point is going to be the vector sum of intensity due to each individual charge. What is that? It is going to be the force acting numerically equal to the force acting on unit positive charge placed here. We have learned what is intensity of electric field. The force acting per unit charge on an infinitesimally small positive charge placed at that point. Suppose intensity of electric field at this point due to Q1 is represented by vector E1. Due to Q2 being negative, it will be in this direction, vector E2. Due to Q3, due to Q4 being negative, unit positive charge placed here will be attracted, E4. Due to Qn being positive, this will be intensity of electric field. So due to each of these charges, I have shown intensity acting at this point, intensity of electric field at this point due to each of these charges. Therefore, resultant electric field intensity here will be, by principle of superposition, it will be vector E is equal to vector E1 plus vector E2 plus dash 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 plus vector En. This is principle of superposition of charges. We have applied for force between multiple charges as well as how to find resultant intensity of electric field at a point due to these charges. Now,